All right, let's dive right into the heart of the matter, the science behind climate change and the role of greenhouse gases in global warming. Now, when we talk about climate change, we're referring to significant changes in global temperatures and weather patterns over time. And this isn't just a theory, it's a fact backed by decades of scientific research and evidence. Now, here's where greenhouse gases come into the picture. You see, our planet is sort of like a greenhouse. The sun's rays enter the Earth's atmosphere, warming the planet. Normally, some of this heat escapes back into space. However, greenhouse gases, which include carbon dioxide, methane, and nitrous oxide, act like a blanket, trapping this heat and causing the planet to warm up. This is what we call the greenhouse effect. This process is entirely natural and has been occurring for millions of years. But human activities, such as burning fossil fuels, like coal, oil, and gas, have drastically increased the concentration of these gases in the atmosphere. This has enhanced the greenhouse effect, causing the Earth's average temperature to rise. This phenomenon is what we refer to as global warming. And the consequences of global warming are severe. We're talking about more frequent and intense heat waves, rising sea levels, melting polar ice caps, and shifts in plant and animal habitats. So, understanding the science behind climate change and the role of greenhouse gases in global warming is the first step towards mitigating these effects. We have to remember that we're all in this together and that every little bit helps. So, let's continue to educate ourselves and others about the science of climate change and commit to taking action to reduce our greenhouse gas emissions. Because the future of our planet depends on it. All right, let's shift gears and talk about renewable energy sources as alternatives to fossil fuels to reduce carbon emissions. So we've established that burning fossil fuels for electricity, heat, and transport is one of the main drivers of global warming. But what if we could replace these dirty fuels with clean, renewable energy? Well, that's exactly what we're starting to do. Renewable energy comes from sources that naturally replenish themselves. I'm talking about the sun, wind, water, even heat from within the earth. Let's take a closer look at some of these. First up, we have solar energy. Simply put, solar power is energy from the sun that's converted into thermal or electrical energy. It's the cleanest and most abundant renewable energy source available. The potential here is enormous. After all, the sun isn't going anywhere anytime soon. Next, we have wind energy. Harnessing the power of the wind is hardly a new idea. Think windmills or sailing ships, but modern wind turbines have taken things to a whole new level. They're a great way of generating electricity, especially in areas where wind speeds are high. Then there's hydropower. This involves using water to generate electricity. The most common method is through a dam on a river. The water flows through the dam, turning a turbine, which then generates electricity. And we can't forget about geothermal energy. This comes from heat, deep within the earth. We can use this heat to generate electricity, or even heat buildings. Finally, there's biomass and biofuels. These involve using organic material, like plants, waste, and even algae, to create energy. The beauty of these renewable energy sources is that they emit little to no greenhouse gases once they're up and running. Plus, they're sustainable. Unlike fossil fuels, they won't run out. So they're a crucial part of the solution to climate change. But here's the thing. While we've made significant progress, we still have a long way to go. We need to continue to invest in and develop these technologies and make them accessible to everyone, everywhere, because the sooner we can transition to a world powered by renewable energy, the better off we'll all be. All right, let's delve into our next topic, which is about examining the impact and effectiveness of international climate change agreements and policies on reducing greenhouse gas emissions. Climate change is a global problem, and it requires a global solution. That's why nations around the world have come together to negotiate international agreements aimed at reducing greenhouse gas emissions. Let's discuss some of the most important ones. First, we have the Kyoto Protocol, which was adopted in 1997. This agreement, under the United Nations Framework Convention on Climate Change, committed many industrialized nations to reducing their greenhouse gas emissions. However, not all countries met their targets, and some major emitters, like the US, didn't ratify the agreement. Then, there's the Paris Agreement. This treaty, adopted in 2015, aims to limit global warming to well below 2 degrees Celsius above pre-industrial levels, and to pursue efforts to limit the temperature increase to 1.5 degrees Celsius. The Paris Agreement is unique because it requires all countries, not just the wealthier ones, to set emissions reduction targets. These agreements have been pivotal in raising awareness and prompting action. But have they been effective in reducing emissions? Well, it's a mixed bag. While emissions have slowed in some countries, global greenhouse gas emissions have continued to rise. One reason for this is that these agreements rely on voluntary commitments, and there are no penalties for countries that fail to meet their targets. Plus, the targets set so far aren't enough to limit global warming to the level set out in the Paris Agreement. That's not to say these agreements aren't important. They are. They represent a global recognition of the problem and a commitment to address it. But they need to be backed up by strong national policies and actions. We need to set more ambitious targets. And we need mechanisms to hold countries accountable. We're in a race against time here. And while we've made some progress, we need to pick up the pace. Because when it comes to climate change, every fraction of a degree and every year we delay matters. Moving on, let's talk about the role of reforestation and sustainable land management in sequestering carbon dioxide and mitigating climate change. Forests play a crucial role in our fight against climate change. They're like the lungs of the earth, breathing in carbon dioxide and breathing out oxygen. This process, known as carbon sequestration, helps to reduce the amount of carbon dioxide in the atmosphere, which in turn helps to mitigate global warming.
Reforestation, which involves planting trees to restore or create forests, is a simple and effective way of sequestering carbon.
It's estimated that forests absorb around 1/3 of the carbon dioxide released from burning fossil fuels. So, planting more trees could significantly ramp up this carbon capture. However, it's not just about planting trees, but also about managing them sustainably. We need to ensure that forests are protected and that trees are not cut down at a faster rate than they can regrow. This brings us to sustainable land management. This involves using resources in a way that maintains the land's natural productivity, diversity, and ability to function as a healthy ecosystem. It includes practices like agroforestry, which combines agriculture and forestry, and conservation agriculture, which involves minimizing soil disturbance, maintaining soil cover, and rotating crops. These practices not only help to sequester carbon, but they also boost biodiversity, improve soil health, and enhance food security. So it's a win-win. But here's the thing. Despite the clear benefits of reforestation and sustainable land management, we're still losing forests at an alarming rate due to activities like logging and land conversion for agriculture. This not only releases the carbon stored in trees, but also reduces the capacity of forests to absorb carbon in the future. So, we need to step up our efforts. So we need policies that incentivize reforestation and sustainable land management, and we need to enforce laws that protect forests. Because every tree matters in the fight against climate change. Let's not forget that. Now, let's move on to an exciting and innovative field in the fight against climate change: the advancements in carbon capture and storage technology. Carbon capture and storage, or CCS, is a technology designed to prevent large amounts of carbon dioxide from being released into the atmosphere. The idea is to capture carbon dioxide at its emission source, such as power plants and industrial sites, compress it, and store it underground. It's like putting carbon dioxide back where it came from, so to speak. There are three main steps in the CCS process: capture, transport, and storage. During the capture phase, carbon dioxide is separated from other gases produced when fossil fuels are burnt for electricity generation or during industrial processes. The captured carbon dioxide is then compressed and transported, usually through pipelines, to a suitable site for storage. Finally, it's injected deep underground into rock formations, often at a depth of 1 kilometer or more. So, how effective is CCS? Well, it's estimated that this technology can capture up to 90% of the carbon dioxide emissions produced from the use of fossil fuels in electricity generation and industrial processes, significantly preventing greenhouse gas from entering the atmosphere. The technology itself isn't new. It's been used in the oil and gas industry for decades. But applying it to carbon emissions on a large scale is a relatively recent development. And while CCS is promising, it's not without challenges. These include high costs, energy penalties, and the need for large-scale infrastructure. Plus, we need to ensure that the stored carbon doesn't leak back into the atmosphere over time. But here's the deal. Even as we transition to renewable energy, we're likely to continue using fossil fuels to some extent in the near term. CCS can be a bridge to a cleaner future, capturing emissions as we work to reduce our dependence on fossil fuels. So let's keep pushing for advancements in this technology and for policies that support its development and deployment. Because every tool we have in our arsenal counts in the fight against climate change. And CCS could be a game changer